Oh,
Been done well. Alright, so we're going to do with the scale drawing and models. Okay? That's why that paper I just put on everyone's desk, you need it because you will draw some of this stuff. Essential question. How would you compare and contrast scale and scale factor? Vocab, scale drawing, scale model, scale, scale factor. You got what?
the column.
Where?
By scale.
So put it.
All right.
Yeah, right, both ways.
On
Both
yours.
ways, you.
On yours.
Both ways, you.
Alright, so first thing we're going to talk about is that scales. The fun scale type stuff. This is actually goes perfectly with what we are doing, which is why we are, combining them. So we're doing scale drawing and scale model. Have you guys heard of scale drawing or scale model?
No.
But you have.
I heard of drawing.
Has anyone ever put together a model?
Yeah.
Project.
It's called Legos.
We did the pyramid.
Called
Lego, remember?
Oh, yeah. You have to the pyramid.
Now, the difference between your pyramid
And
and a scale model
it's a scale.
is the scale has to be more specific dimensions. For example, if anyone goes into architecture, you are going to have to use this lesson a lot. If you go into interior design, you're probably going to use this. Because what this is that's making something really large or really small and making it a size that you can work with. So for an example, where do you guys live?
Liberal.
Be honest, be serious, where do you live?
Liberal.
You live in Liberal, Kansas. Can you guys look at the entire state of Kansas on your own?
Yeah.
Really?
Yeah, it's called Google Maps. Google Maps.
Oh, okay. So, see if I can find mine.
Going old school.
You guys all live in Liberal, and we're all in Liberal. Usually half the state of Kansas.
A map.
Half the side. Nope. I want everyone to find and stand on Liberal. Yes, stand on Liberal.
right now. Liberal's right there.
That's not Liberal.
I don't know where it is. Oh. Garden City. So this is right here, everybody.
Oh, wow, this is sad. You guys
Right
can't
there.
come
Oh,
out.
it's under your hand. Everybody step on it.
Everyone stand on it.
Oh, yeah.
Oh,
I don't see you guys standing on Liberal. I still don't see you standing.
I see everyone stacking the feet up, but not everyone.
You're not even in Liberal. You like toe in Liberal. What you want?
Wait a second. We don't have to step on it. We're right here.
We're on that map. I want you on Liberal.
Right there.
Oh, yeah.
Why aren't you guys reading on Liberal?
Oh, yeah.
That's small.
Wow.
But that's Liberal. It says that's Liberal. Why aren't you guys on Liberal?
Because I'm not. Because we're liberal.
That is a scale drawing. Okay, now you just ripped my map.
Oh, no.
Oh, yeah. Oh, yeah.
This is a scale drawing. 3, 2, 1. It is a scale drawing because you've had somebody who went out, and please get in your seat. Somebody who has went out and measured and figured out how to size this so it fits on a piece of paper you can use. Okay? That's how we get and why we use scale models. Architects, I brought that up because they're the ones who build things. They are going to design a building and have a smaller scale model setting out before they go and build it. My Legos, they're not exactly scale, but you see all those buildings up there?
Yeah.
That's because those are models. If they were scale models, they would have been built exactly right so that way the length and width in comparison is the same as the ratio to the actual building.
So like a blueprint?
A blueprint. We have an emergency map hanging over there on the wall. That's more of a scale drawing. A at least a hallway. Okay? So a scale drawing or a scale model is used to represent an object that is too large or too small to be drawn or built at actual size. So a lot of the stuff I have, that is too large. There is no way I could fit the Statue of Liberty in this school,
Or could
much less in the schoolroom.
You could fit a Megan in here. What?
I could not fit the actual in my classroom. I have 3 different White Houses. No, never mind. One of them got taken down. I have 2 different White Houses in this classroom. The actual White House does not fit in this classroom. There is 2 different Eiffel Towers, but the actual Eiffel Tower does not fit in here.
It's in London.
There's a shit guy.
It is. Paris. No, it is.
Hey,
It's in Paris.
quit throwing in everything else. Listen to what I'm talking about.
Oh, we're talking about buildings.
Uh-huh. None of those buildings can actually fit in my classroom. But the models are in the classroom. That's what we mean by model. It's used to represent an object that is too large or too small. Those are all too large.
Like a Subway, like, there's a poster of Subway, this is on the scale.
That's what it means. That's not the actual size of the sandwich. Okay, there's also the too small. Too small would be like, you guys are in science, right? Have you ever seen a picture of a germ
No.
or bacteria?
No.
In your entire life, you've never seen a picture of a germ or a bacteria?
Oh yeah. No.
Or DNA or any of that?
It's small.
Yeah,
I need a
right.
microscope.
Pull it up on the computer, miss.
What's sad is that I have to do this because I know you guys have seen this stuff before.
Really? Ask Mr. Callejon. Oh, I thought that was
Uh-huh.
just something
This
that
is
goes
a
in the
strand
air.
of DNA.
I thought there was a piece of stair.
This is a strand of DNA. This is what makes you who you are. Now, does your DNA actually look that size?
No. Yeah.
It's as big as my arm. My whole arm would have to look like that.
Whoa.
So is this really big or really small?
Really big.
That's a really small.
Why do you look at you though? It's like,
Wait, there's a chromosome right there. Chromosome. Oh yeah. You know what a chromosome is?
Pictures of bacteria. Of the germs that make you sick.
Diabetes.
If the germs were this size, it'd be a whole lot easier to avoid them.
Diabetes.
And also be a lot scarier.
Because then they'll eat you.
Okay?
Because if you
So this is what they mean by drawn to scale. These pictures should be drawn to scale. There's something really, really, really small that you need a very powerful microscope to see blown up in size so you guys can see without straining yourself. Alright? Next, we have scale. Long definitions on these. Scale is determined by the ratio of a given length on the drawing or model to its corresponding length on the actual object. So to find scale, you are going to find the measurement of the model or the drawing, and you're going to find the measurement of the actual, and you're going to compare those two. I'm not doing anything.
word.
So the key to remember from this one, and I will admit I have forgotten this several times and have to remind myself every single year, you want the drawing or the model over the actual. So the drawing or the model over the actual.
and then we will get to actual practice problems.
Homework from yesterday on the website. You did?
Why?
When I finally saw your message.
Yeah.
What did you
Did
say?
you get my message?
When I finally saw your message, I posted it. So did I get your message?
What did you say?
I guess so. Well, I was trying to.
Is everyone ready? No. Why?
I have petrol.
Do not break it, and I definitely need it back. Okay, everyone ready? Let's do some scale drawing and models practice problems. First problem. Suppose a model of a dragonfly has a wing length of 4 centimeters. If the length of the insect's actual wing is 6 centimeters, what is the scale of the model? Nice long word problem, right? What I want you guys to do is I want you to find and write down in your notes, not the whole thing,
In the student page?
what is important.
In the student page?
You can do it on teacher page.
Wing.
I have no clue what I just said. Sorry. There you go. Find and copy what is important. Boys. Hey, Omen.
Yep.
That makes it even more obvious. Take your earbud out. I want to see it taken away from your hoodie, away from your neck, and put up.
That's tough, brother.
So what's important?
Model is 4 centimeters.
Is it important to know that it's a model?
Yeah.
Okay, so we have that the model is 4 centimeters.
No, the wing is.
I'm not joking.
I'm not looking.
Cool, it's wing. Is it also the wing on the other one?
Yeah.
Talking about same thing, but what we need to know is model is 4 centimeters. What else do we need to know?
Actual 6 centimeters.
Actual 6 centimeters. That's what you guys should have written down.
That's exactly what
Because now you are going to have the model over the actual. How long is the model? For what? Over what?
6 centimeters. So, there's one. Yeah. It's not too big. Oh, yeah, it is. Yeah, it is.
Why is it 1/2 or 2/3?
2/3. 2/3. 2 out of 10. 2
Over 50 is 1/3. You can put it.
Okay,
Ignore the pen.
but it wants an actual, right? Okay, hold on. When we find this, what we're going to do is we're going to set up a proportion. This is why we follow the solid proportions. It is going to equal. Scale means that you need the model to be a 1. So we're going to put a 1. One centimeter over. Do we know what the actual would be if the scale is 1?
No.
You guys know off the top of your heads right now?
Wait, what?
So we're going to put X.
Wait, what would the model be? What?
When you're finding scale, get model down to 1. So you know that your model or your numerator will have to be a 1 over here. You're trying to find out what the actual will be. Is that all right?
So the model always goes in.
Model over actual every single time.
So if I need scale, you change it.
Huh?
If I need scale, you change it to 1.
You change model to 1, always. Okay, does this look familiar?
Yeah.
What did we do when we have problems like this?
Cross them.
You do cross. So what is 6 times 1? What is 4 times x? Where's your variable? On the right? What operation do you see? Multiplication, what's the inverse?
Division.
What do we divide by? 6 divided by 4.
1.5.
Don't forget your label. So it is, hold on, I gotta rewrite that. It is going to be 1 centimeter is equal to 1.5 centimeters on the actual. That's your scale. Okay? That makes sense? Completely confusing one? Are you ready to try another one?
You divide 6 by 4.
Okay, so let's look at the next one. Is everyone ready? Pillars of World War II Memorial in Washington, D.C. are 17 feet tall. A scale model of the memorial has pillars that are 5 inches tall. What is the scale of the model? How are we going to set it up?
5
Why 5 over 17?
over.
Model over actual. But it's not just 5 and not just 17. 5 inches and feet. Then put it equal to. Which one of these do we want down to a 1? All of you are confused. Okay. The numerator, not the top. The model wants to get down to 1 inch because we want every single scale answer to look like 1 inch, 1 foot, 1 whatever it is equals, find your scale. Do we know what this is?
No.
So what do we put? How do we solve? Cross what? Cross what? What is that called? Another word for cross multiply is cross. Someone's got it.
Proportional.
Not proportional, cross. Someone won't go. It means to multiply. Go. Cross products. I didn't hear it then, I'm sorry. What is 17 times 1?
17.
What is 5 times x?
5x.
And they are equal. What do we do now?
Divided by 5.
Why divide by 5?
Because you want to get rid of 5, so it's only
Okay. What's 5 divided by 5?
No, x. It's
Equals.
3.4.
Now here's a hard thing. 3.4 what? How do you know it's feet?
Because 7
the actual is
and
the
you divide
Feet. Actual feet. The x would have had feet. So it's 1 inch equals 3 4/10 feet.
and you have to do decimals, because last time you said you don't really know.
This one just leave decimal. Unless it tells you how to round, leave decimal. Okay. Oh, the round down that was from yesterday. That confusion was that was asking about care packages, right? If I give you boxes and I say you gotta fill it up and send it, are you gonna fill up the box like halfway through? Does anyone ever like load a dishwasher or load a washing machine? Does mom let you fill it only like halfway full and then run it? Really?
No,
Oh, we always got in trouble. We have to fill it. You make sure it's full. There's too many dishes in this household. You make sure it's full before you run it. That's the place to watch.
I just throw them away.
That's the plate.
I hope you get a very good paying job if you're gonna just throw everything away. All right, ready for the next one?
Yeah, plastic.
All right. The length of a model bridge is 16 inches. The actual length of the bridge is 50 yards. What is the scale of the model? Go ahead and solve this problem. Turn the page. You can have this as a fraction or a decimal. A mixed number or a decimal. No, what is this? Okay, that looks like big comma. Okay. Yeah.
Watch it, Daddy.
No.
How is the name scale?
Daddy,
One
you need to
something.
go to the
Oh, what is the amount that just give me that final thing? Yes. You just have to write it like your math is open. Oh. Much better.
Miss, can I get some?
How much you got then? Not enough.
37 minutes. I've done 37.
Not enough.
Don't even have enough. There's a problem. What? Press F to pay respects. Yeah, F is a trap.
Otherwise you would have been. Yes. Okay, you guys ready? We have one more vocab to go over.
Press F to pay respects.
Scale factor. Now, scale factor is a little bit different than scale because scale factor is a little more specific. On those scale factors, do you have the same units?
No.
On the scale factor, or the scales, not scale factor. On scale, on those last three problems that we did we have the same units followed?
No.
No, because we had like inches to feet, inches to yards, centimeters to
Feet.
yeah, whatever it was. But they all had different units, right? Yeah. Scale factor gets a little bit more specific. It's when the scale and the actual, when the model and the actual, whatever you want to call it, and the actual have the same measurements.
On a ring.
So when the scale drawing or model and the actual have the same unit of measure and can be written without any units at all. So all those three answers you gave me, you have to put the labels, right?
Yeah.
When it's the same label, you don't have to. And when it's asking for scale factor, you don't have to put the label. We'll just keep working. You guys ready? Who's not ready? Come on, next. Look at that, those problems.
I just like numbers.
So the next problem we have is the blueprint of a skateboard ramp shows that its length is 11.4 inches. If the scale on the blueprint is 1 inch equals 6 feet, what is the length of the actual skateboard ramp? So this one isn't quite scale factor yet, but can we solve it? What do you guys need to write down? What's important for you guys? 1 inch equals 6 feet, and it doesn't matter where you got it from.
11.4 inches.
And the 11.4 inches. Okay, so how would we set this up?
Multiply.
Model over actual.
Oh,
Model over actual. So we have the model over the actual.
I got an idea.
6 over 11.4.
Why 6 over 11.4?
Because
That's what you turn it to.
How about 1 inch is 6 feet? So we can put 1 inch over 6 feet
okay.
equals, where does that 11.4 go?
Oh,
Numerator.
Why is it the numerator?
because it's over scale.
Because of the inches tells us, what else tells us? Is this the actual or the model? That's the model. Model always goes in the numerator. So 11.4.
Over X.
Why over X?
Because
You don't know what it is.
Okay.
you don't know what it
Can
is.
you solve it?
Yeah.
Go ahead.
Easy money. I gotta find this answer.
Math is obvious. Nope. What's the label? Yeah, so why don't you write that down? You just have to get it. Yes, you're good. Except, hold on. Hold on. But it's not one. This one is actually set to 11.
Yeah.
Work, but it's not 1 inch. It's set to 11. For you guys, when you write this one, you're not putting 1 inch equals whatever your answer. You're putting 11.4 inches equals your answer, because this one is set to 11.4, not to 1.
11.4 inches.
That equals whatever your answer is. All right. So everyone have a seat, because I'm going to show you some scale factor.
Heads or tails? Heads or heads?
But your bottom looks
It's a dog.
all right. 3, 2, 1. That's how you guys solved it, right? Well, we're going to do it slightly different now. 3, 2, 1. Scale factor. What scale factor is going to look like is we are going to put, you have your 1 inch to 6 feet, right?
Yeah.
Are these the same units?
No.
No. These are not the same units.
So there's gonna be a scale.
So you will multiply, because you know 1 foot is equal to 12 inches, right?
Yeah.
So that way your feet can cancel out, your inches can cancel out, and we're going to multiply. What's 1 times 1? What's 6 times 12?
72. 48.
So this is your scale factor. 1 over 72 is your scale factor. Does that make sense?
Yeah.
All I did was get them to the same unit so we could cancel out the units.
Okay.
And it's easier to make feet into inches than trying to make the inches into feet and then simplify. So that's the scale factor. Now how you use the scale factor is right here. Your model is 11.4, right? Okay. So there's more better. What that means is for every 1 inch on the model, or 1 unit on the model, you have 72 units in real life, right? 1 over 72 is equal to 11.4 over x. What's 1 times x? 1x. Equals. What is 72 times 11.4? Huh?
Is that x or equals? Oh, it's times.
820 what? 20.8? Is that what you said?
Yeah.
No, you're right. This one has a possibility of 2 answers.
Oh,
Okay, so what is the actual length? You guys got what answer?
Oh, it's 11.4 which is equal to 8.4 feet.
You have 68.4 feet or 820.8 inches. Yes.
68.
Okay, you guys went through and you solved it the way I had already showed you, right?
Yeah.
Everyone here said, okay, 1 inch over 6 feet equals 11.4 inches over x, right?
Yeah.
And it's asking what's the actual length, and you said, let's cross multiply.
What do you do that? You like
Okay?
circle?
That's how I do it. What is 6 times 11.4?
6 times 11.4 equals 68.4.
Equals 1x, right?
Yeah.
Now the label was, this is 68.4 feet. Did it tell us to do it with scale or scale factor?
No.
No, neither one, so it doesn't matter. You can have 68.4 feet or 820.8 inches.
So is there gonna be like 2 answers on every one?
I will have 2 answers. You only have to worry about which one does it tell you.
Okay.
Okay, so I do not expect you to do both of these for each and every single one.
You get choose one.
My answer key will have both of them, and I'll figure it out. You guys want to check this?
No. Wait,
Oh,
what?
no, not like the equation check.
Oh,
Take 68.4 times 12.
68.8 or 20.8 divided by 68.4 equals 12. That's the next one.
Hey, how many inches are in 1 foot?
Not.
So if there's 12 inches for every single foot, you have 68 feet and then some.
And that's 4 inches.
So you multiply each one by 12. Okay? Are you good with that? You guys think you got it?
Yeah.
Can you erase some stuff?
Yeah. Everything.
I think we're ready for homework.
Turn a page. Are you sure you're ready?
Yeah, I'm ready.
Are you sure I didn't throw in something that's tricking you?
No, nothing's tricky.
I like to trick people though. A map of the Natural History Museum shows that the dinosaur exhibit room is 7 and 25 inches wide. If the scale on the map is 1 inch equals 8 feet, what is the width of the actual exhibit room? This is one time I will ask you, find me both answers.
What?
Okay, what is the first way you guys know how to solve this?
On the student page?
Yes, student page.
Go ahead. Wait, we have to find both?
I want you to find both. So what's the first way? You guys already know this. What are you going to first set up?
1 inch over 8 feet.
Equals what?
7.25 inches over x.
Pause, do not solve yet. Put your pencils down. Do you know how to solve this? Okay. The second option is you have 1 inch over 8 feet. Is this a scale or is it a scale factor?
Scale.
This is a scale. Get it to a scale factor. Are these the same labels?
No.
Can we get them to the same labels to cancel out? Okay, so multiply. What do we know about inches and feet?
They 12 inches are 1 foot.
So do we want 12 inches over 1 foot or 1 foot over 12 inches? 1 foot over 12 inches. Now, why do I want you guys to set it up like that? What's going to happen?
It's gonna you can cross out the inches and the feet, and you multiply the numerators.
Inches cancel out. Feet cancel out. What is 1 times 1? What is 8 times 12? Huh?
36.
Okay, I thought somebody said 36 and that confused me. Do you need any labels? No, this is your scale factor. Now you can use that as a 1 over 96 equals what? 7.25 inches. That one will have an answer in feet. This one will have an answer in inches.
Alright, so you want us to do the other one?
I want you to do both of them. So solve both. Okay?
Mm-hmm.
So the other one. Miss Lomar?
Like what is he? I told you this.
Luis, August, Alberto,
I took my stuff or what?
did you solve this one in red over here?
Miss,
Yeah, it's
I
on
took my stuff.
It's on here.
Miss,
Yes, take your stuff just in
what
case.
do you think from me?
Okay.
She says don't worry.
Yeah, bro. There's soap everywhere.
Yeah.
Yeah, when you say, give like 5 seconds to
You got it.
move your legs and leg. I like what I see.
Luis, what are we doing? Go. The inch one isn't right. Alright, looks like the biggest problem we're having is just not copying problems down on, right? Yes. What? Put an X under that 2 or 7.25. Yep.
Oh.
Yep.
I thought you were supposed to.
Nope, once it's blank, you just solve it. Dude, you lost your math. I don't know. Which one do you think is? These are the same exact one.
I know how you do like little buttons and like and then you can find it. You can do like that's what you can do.
Okay. Don't need a look.
Thank you for your card information.
You got it all worked out. Yep. Wait, nope, labels on.
That would be good.
Yep.
Oh, my card is
Alright guys, I'm getting a little bit confused on the labeling. So, does this ask us for a scale factor, or a distance? This one's asking us for a distance, so you don't need to put an equal sign. Your first one, you should have 58 what?
Feet.
Feet, just 58 feet. I don't even need it equals anything else. Just put 58 feet and you're done. The second one, what did you get? 696 what? Inches. That's it. Okay? Any more questions on that?
No.
All right, let's get to the last style of question. Gary, come on over. I'd walk behind everybody, not in front of the pictures up. So on this one, let me unfreeze so you guys can see it. Lila is painting a mural at a community center on a wall that measures 18 feet long and 12 feet tall. Make a scale drawing of the mural. Use a scale of 1/4 inch equals 3 feet. Okay? Watch what I do because I'm not going to talk over her. Okay? Let's see. Copy that down.
class will be meeting today and Friday this week at 3:30 p.m. Students, my name is Patricia Patrick and this Friday. Attention students signed up for the talent show. Tryouts will be this Friday at 4 p.m. and at 3 p.m. May the following participants be offered at this time: Joshua Vasquez, Alexis Castro, Pedro Catalan, John Garcia, Abigail Hernandez, Victor Mendoza, Mia Nunez, Aiden Portillo, Julia Romana, Alexis Acevedo, Stephanie Bernal, Isaac Cardoza, Cynthia Cruz, Christian Davis, Fabian Franco, Ron Galindo, Maria Heck, Elia Lucero, Brian Marino, Rodolfo Marino, Adrian Wilson, Ruby Pulido, Emmanuel Ramirez, Kevin Sepulveda, Kaylin Stevenson, Bria Trujillo, Isaiah Tavares, and Carly Weisenkrantz. Those students need to report to the office at this time. Thank you, and remember, it's a great day.
And what we're doing is we're making this smaller so you guys can actually draw it. That's what that paper's for. So I did the exact same thing. Set it up. Model over actual. Cross multiply. Divide. So my model is going to be 1.5 inches long. But I got to do it a second time for the width. So then you have 1/4 inch for 3 feet is equal to x over 12 feet. Do it a second time, okay? Is everyone paying attention?
Yeah.
Not everyone. Because then we cross multiply again. You get 3x equals 3. Because 1/4 of 12 is 3. Divide by 3. X equals 1. The width is 1 inch. What you will then do is you would take that paper I gave you at the very beginning of class when you're still working on other stuff, that grid. Okay. Get the right thing. Each one of these is 1/4 inch. So all you're going to do is you need a length of 1.5. There's 1, 2, 3, 4. There's 1 inch. Here's a 1/2 inch. 1, 2, 3, 4. There we go.
This one, you only give us one.
There's your model. I know. But here you go. If you guys ever have homework, do you think I want you to use a full sheet for every single one?
Yes, sir.
Especially since it only took up this little bitty corner up here. Do you think I want you to just do it in the middle and have to get a new page for each one?
Yes, sir.
No, because now you get to do this. Here's, let's say, problem number 1. Let's do problem number 2 right next to it. Okay? No,
What about a leave?
I know.
You're
You
not
get
gonna
your homework tomorrow.
Actually?
You guys got lucky today. Unless you freak out, and then I'll just give it to you.
No.